Hello, this is Mr. Stansbury. I'm going to take you through the notes on Formulae, which is the plural of formula. So I can use Formulae to solve various real-world problems. Okay, so let's take a look at some examples here. Example 25. When a rock is dropped off a cliff, the total distance from the base of the cliff, d meters, is given by the formula d equals 250 minus 1/2 gt squared, where t is the time the rock has fallen in seconds, and then g is the gravitational constant 9.8 meters per second squared. Find the distance from the base after 4 seconds. So we're going to want to just use this formula here over and over. So we've got d, distance is going to be 250 minus 1/2. And they say that g is the gravitational keyword in here is constant. So it's always 9.8 meters per second squared. So we're going to just do 1/2 of 9.8. Right? And then let's see, that's the gravitational pull, and then times t squared. So in this case, t is going to be 4 squared. Okay, so all we need to do is figure out what that is. Okay, so just to kind of go back and figure out what the heck this formula even means. D is the distance. This here is like what happens with gravity. There's a gravitational pull. It's going down, so it's actually getting closer and closer to the bottom of the cliff because the distance is the distance from the base of the cliff. So basically, the base of the cliff meaning the bottom of the cliff. Okay, so that means that this cliff has to be 250, meters tall. Okay. So just so you kind of know what we're up to. So let's calculate this and figure out what our distance is. Okay, so we've got our little scientific calculator here. This will obviously work just fine on a graphing calculator too. We're just going to enter it in as it says. So 250 minus 1/2. I'm just going to do 0.5 times 9.8 times 4 squared. And that should give us our answer. 171.6. So our distance is 171.6 meters from the base of the cliff. So it's basically from the bottom. So again, if we've got here's our picture here. Here's the jagged rocks below. Here's the top of the cliff. This is 250 meters tall. Okay. So after 4 seconds, it's about right here, 171.6 meters from the bottom. Okay, just so you kind of get an idea what's going on. All right, let's take a look at B. The time it takes for the rock to get to 100 feet above the base of the cliff. So now, again, we're going to keep using this formula over and over again. But now we know the distance, and now we got to figure out what the time is. So really what we want to do is just get rid of that G and put in a 9.8, right? So now we know the distance is going to be 100. We got to figure out what the time is. So the distance is 100 equals 250 minus 1/2 9.8 times t squared. So now we're trying to find out what the t is instead. So what we got to do is we got to solve this thing for t squared. So first things first, we have to figure out what to get rid of first. Do we get rid of the 250, the negative 1/2, or the 9.8, or the square? Okay, so the first thing we want to get rid of here, again, going in reverse order of operations, is we want to subtract 250 from both sides. Okay, so we get negative 150 equals negative 1/2 times 9.8 times t squared. Okay, so now we want to get rid of the 1/2 and the 9.8. So let's try this. Let's just find out what half of 9.8 is. That might make it a little bit simpler. So that's 4.9. So we really are doing negative 150 equals negative 4.9 times t squared. Okay, so we want to get rid of that. We got to divide now because that's negative 4.9 times t squared. So we got to divide by negative 4.9. divide by negative 4.9. And that's going to leave us with t squared equals, let's see here. So we got negative 150 divided by negative 4.9. That gives us 30.6122. Okay. Now, last step to get t by itself is we square root both sides. So we're going to end up getting t equals. Now we're just going to, instead of going back and pushing square root and then retyping that whole thing, all we're going to do is just do second square root. So we're going to do the square root, and then we're going to do second answer. And it's going to take the square root of whatever our previous answer was. Okay, so push enter on that, and we get 5.53, we'll call it. 5.53. Now, if you remember, whenever you take a square root of a number, an even root, then what you have to do is you have to do plus or minus. So, since this is talking about time, 5.53 seconds makes sense. Negative 5.53 seconds does not make sense. So we're going to stick with just the positive answer. Okay? All right. C, how long will it take for the rock to land at the base of the cliff? So then we want to know when the distance is 0. So I'm going to do 0 equals 250 minus 1/2 of 9.8 times time squared. Okay, so first thing, we got to get rid of the, that's terrible in there. Let's fix that so that it's actually readable. Right, so this is minus 1/2 times 9.8 times t squared. So we got to get rid of the 250 first. Right, so subtract 250 from both sides, and we get negative 250 equals, we already figured out earlier that negative 1/2 times 9.8 is negative 4.9 t squared divided by negative 4.9, and we get t squared equals, let's see, let's take a look at this here. So we get negative 250 divided by a negative 4.9. And when you're doing this, if you want to just do 250 divided by 4.9, that is a perfectly great shortcut to take, because you know that the negative divided by negative is going to be a positive. So anyway, 51.02. And then we got to take the square root of both sides, right? Don't have to put the 2 up there, but just to kind of help out once in a while. Time is going to be, so now we do second square root, second answer. Takes the square root of that answer, 7.14. So 7.14, and that would be seconds. And again, we're only going to take the positive because it wouldn't make sense to put the negative time on there. You can't have negative time. Okay, let's take a look at some other examples here. Okay, volume of a cylinder of radius r and height h is given by V equals pi r squared h. Find the volume of a cylindrical can with a diameter 12 inches and a height of 8 inches. So we're just going to basically plug in information into this, right? Oops. So we are going to do V equals pi is pi, radius. Now this says the diameter is 12, so we got to take half of that to come up with the radius, right? So 12 over 2 gives us 6. So that's 6 squared, and then the height is 8 times h. So now we're just going to multiply those out. So we're going to go pi times 6 squared times 8. It's going to give us our volume here, and we get 288 pi. That's a 288 pi is a fine answer. What you want to do, that's not a very satisfying answer. So if I push this little double arrow here, that's gonna should turn it into just a decimal without the pi in it. So 904.777 we'll call it. And that's going to be in what, inches? And since this is volume, this is inches cubed. right? So either one of these is officially fine. I like this one a lot better because that gives me a lot better picture instead of 288 pi, but either one is fine. Okay, next thing, find the height of a cylinder with a radius of 6 centimeters and a volume of 112 centimeters cubed. So now we know the volume is 112. And let's see, we know that pi is still pi, right? And now we know the radius is 6. And now we got to figure out what the height is times h. So now we're just going to solve for h. Okay, so now what we really want to do is do pi times, whoa. Okay, sorry about that. So we're just going to do pi times 6 squared. Pi times 6 squared gives us 36 pi, or 113 point, I'm going to go with 113.10. Oops. So that's 113 point, what did I say, 10? Times h, right? So now we have to divide both sides by 113.10. 113.10 to figure out what our height is going to be. So with our calculator, we're just going to really want to just do 112 divide by our second answer. Divide by our answer is going to give us 0.99. 0.99, and in this case it's centimeters is what the height should be. Okay, last one here. Radius of a cylinder whose height is 80 millimeters and has a volume of 1,160 centimeters cubed. So we're going to figure out what the radius is. So we now know the volume is 1160 equals pi times, we're looking for the radius, and we know the height is 80, right? So we got 1160 equals, we want to get r, oops, not r cubed, but r squared by itself. So let's do pi times 80 here. So pi times 80 gives us probably 80 pi. Yeah, that's helpful. And then 251.33, we'll call it, times r cubed squared. Divide both sides by 251.33. 251.33. And we get r squared is, and again, it's really important, you really want to do 1160 divided by your answer instead of this rounded answer, because the more rounding you do before the very end, the farther and farther your answer is going to be off. Okay, so we're going to do 1160. And this works exactly the same on your graphing calculators as well. Divide by second and then answer. And we get 4.615. Now that's the radius squared, so now we got to square root both sides to get that our radius is going to be, so now we're going to second square root, second answer, and we get 2.15, we'll call it. 2.15, and this is millimeters, is what the radius is going to be. And again, negative 2.15 is not going to make any sense, so we just stick with the positive answers. All right. Okay, that's all there is for Formulae. If you have any further questions, please feel free to ask in class. Thanks.